Welcome dear students. Today we will discuss the analysis of the singly reinforcement beam. So in this topic basically we will read about the how to analyze a beam. So before going in that topic we start it like this, that what is the beam first and where it comes, where it needed. So this topic comes under the design of RC structure elements subject which is there in 5th semester. So in this subject, before what is the beam we have. So beam, if I am talking about to you, so the beam we having, that is one flexural member we have. So beam is like one of the other structural elements we have, like column, slab, footing. So like that beam we have. So in that one, the beam we having, so that is a flexural member. So when we are talking about a beam, then beam comes, then it comes that what type of beam it is. So that is why today we are discussing the singly reinforced beam. So what is the singly reinforced beam? That if we are providing the reinforcement, so if we are providing the reinforcement in the tension zone as well as the compression zone of the beam, then we are calling that beam is a doubly reinforced beam. If we are providing the reinforcement only in the tension zone of that beam, then the beam is calling as the singly reinforced beam. So in this topic we will discuss about the analysis of the singly reinforced beam. So after singly reinforcement beam, now the question comes in the mind that what is the analysis, what do we understand by the analysis. So actually we having the two type of problem we have. So one type of problem is the analysis, second type of problem is the design of the beam. So analysis problem, what we have, analysis problem, the section of the beam is given to us, what type reinforcement we have provided, that is given to us. Only we have to find out that whatever load coming on that beam is the okay or not, that can be taken by the beam is so after taking that load on the beam, so how much is the moment of resistance is generating on that beam. So if we are section is given to us, reinforcement we are given to us, only we have to calculate the moment of resistance, then such type of problem we call the analysis of beam. Second type of problem we having, that is the designing of the beam. In that what we have, we only have the whatever load is coming on that beam, where is the beam is, what type of beam is, and on the basis of that we will calculate the what is the size of that beam. And after that also we have to find out the how much reinforcement, what size of reinforcement we have to provide in that one. So that type of problem is known as the designing of the beam. So now today we'll discuss the analysis of the singly reinforced beam. So before going in that topic, you should know that what is the technical terms related to the beam. So you can see these are the technical terms we having. So you can consider like this is the one cross section of beam we having. In this cross section what we have, so we having the width of that beam is the B, and the total depth of that beam is the D. So this capital D is known as the overall depth of the beam. Small b is the width of the beam, capital D is the overall depth of the beam. After that what we have in this there is a one line we have. That line is known as imaginary. This line is an imaginary line which is known as the neutral axis. So neutral axis, what is the role of the neutral axis? Neutral axis actually divides the beam into these two zones. So one zone is known as the compression zone and second zone is known as the tension zone. Now which one, upper zone is tension or compression, or which side we have tension, which side we have compression to the neutral axis, that depends on the what type of beam. So if we are having simply supported beam, so what we have in the simply supported beam, we having upper side we having the compression zone, or downside of the neutral axis we having the tension zone. Okay, so simply supported beam is always having above the neutral axis is known as the compression zone, and the zone below side the neutral axis in the simply supported beam is known as the tension zone. If the cantilever beam we have, so it just become the vice versa. In that case what happened, the compression zone is below side the neutral axis and the tension zone is the above side of the neutral axis. That is in case of cantilever beam. So here we are considering this is the simply supported beam. So in simply supported beam, neutral axis divide the section, that is the above side is the compression zone, downside is the tension zone. Now tension zone, so we are providing first, as we are talking today about this analysis of the singly reinforcement beam, so we only have to provide the reinforcement into the tension zone. So only we have to provide reinforcement in the tension zone, because so this is the main reinforcement we are providing. So now up to the center of that reinforcement from the top surface of the beam is indicated by the small d, and this small d is known as the effective depth of the beam. effective depth of the beam. So what we have, so when we are providing the reinforcement, from where we have to calculate this effective depth of the beam, for that we require some values. So that values we are taking from the IS 456. What that values called? That values would call the cover. Why we cover is it is required? Actually, when we are providing the reinforcement, so we have to assure it that the reinforcement should be inside the beam, that should not be exposed to the environment. Why it is needed? It is needed because if we only providing if the reinforcement is exposed to the environment, then the corrosion will start, and that will overall reduce the life of your structure. So that is why we have to make sure that the reinforcement should be inside the beam, inside the concrete. Okay, so now we are talking about the beam. So in this beam, this is the green line is indicating the cross section of the concrete. Okay, cross section of the beam. So in that we are providing reinforcement. So reinforcement should be embedded to the is there in the concrete. So that is why what we have to do, we have to provide some cover so that the reinforcement should be inside the concrete. So what we have, so for that we are outer surface of the reinforcement, outer surface of the reinforcement to the outer cover of the outer surface of the concrete. The distance is known as the clear cover. That distance is known as the clear cover. So this distance is known as the clear cover. If we add this clear we add the radius of the reinforcement in this clear cover, then we are getting the effective depth. So by using this, we are getting the effective depth, effective cover of. Again I will repeat it, that clear cover, in this clear cover, if we add the radius of the reinforcement, then we are getting the effective cover. Or after getting that effective cover, so you can see the effective cover is equals to clear cover plus half of the diameter of the bar. So this is how we are getting the clear cover. Once we are getting the clear cover, then we deduct that clear cover from the overall depth of the beam. So easily we will get this value of effective depth. So these are the some terminology which we have to remember while solving the question. So in that, maybe they directly gave to you the overall depth, or may directly instead of directly giving that one, they will give the effective depth. So we have to take care of that, what value is given to us and what we have to use it. So on the basis of that we can use it. So the bigger diagram you can see here, this is the reinforcement bar. So this thing is known as the clear cover. And when we are adding the half of the diameter of the reinforcement, then this becomes the effective cover. Okay, so this is how we need to know that, because during the calculation for the analysis as well as the design, we needed these values. So that's why we have to know that what is the overall depth and what is the effective depth. So now we will take the numerical problem on this analysis of beam. So as I told you that we have the two type of problem. One is the analysis, second one is the design. So analysis of problem, what we have, we on the size of the beam is given to us, and the how much reinforcement is given provided, that is also we already know. So we only have to calculate the moment of resistance. So such type of problem is known as the analysis of the beam. And the second time, if we designing of beam is coming, in that case what we have to calculate the size of the beam, what size of the beam we are providing, section of the beam, and how much reinforcement we are providing. So that also we have to calculate. So that type of problem is known as the design of beam. So in this lecture we only cover the analysis of beam, means the size of the beam is given to us, quantity of the reinforcement also given to us, and only we have to calculate the moment of resistance. So this such problem we will solve in this lecture. Whenever any numerical comes in this topic, what we have to take care of that's we have to start the numerical before solving this numerical. What we have to write, we have to always write the given data, whatever data given to us in the question, that we have to write first, then we have to start the solution. Why is it needed? Because sometimes what happened in this problem, the role of the units of the various parameters is also important one. So sometimes what happens, the unit of the one value is given in the different system, in the other system, for other parameter the unit is given in the other system. So what we have, so that is why we need to write the given data first, so that we have to know that where is the if changes in the units is required, so we can easily address here. Otherwise there is a lot of chances we have that we can miss that one. So that is why whenever we start this numerical in which we have to analysis of beam, so what we need to do, we always have to have habit to write first given data. After that we have to start that one. So in analysis of beam, as I told you that we will calculate the moment of resistance, and what we know the size of the section as well as the how much is the reinforcement we are providing. That is also we know. So now for that, before that solving it, we will always write the given data. So what data you may have in such type of problem? So dimension of the section, as I told you that the first they will give to you the how much is the reinforcement, how much is the size of the beam you have. So that dimension is given to us, so you can get to know from that side, okay, this type of problem may be this type of problem we have. Then second data they will give area of the steel reinforcement. So area of the steel reinforcement, actually what is the steel reinforcement in tension? Steel reinforcement in tension, that is abbreviated by like AST. So what is the meaning is tension, that we are providing, this is its type, this is a singly reinforcement beam, and we are providing the reinforcement only in the tension zone. So that is why it is called the area of the steel reinforcement in the tension zone. Okay, so that is the AST. So it means the reinforcement is also given to us, that how much is the reinforcement you have provided, and the material, what material you are using. So in RCC we always use the two materials, one is the concrete and second one is the reinforcement. So for that grade of the concrete and grade of the reinforcement is also given to you. From there we will get the value of, from here, so grade of concrete is given to us, then we get the value of FCK, that is the characteristic strength. That is the characteristic strength of the concrete. For example, if M20 grade of concrete given to you in the question, so what you have to do, in that question FCK is for you is the 20 Newton per mm square. Similarly, if when the grade of steel given to you, so that is generally we write like this, that Fe 415 or Fe 250 or Fe 500. So in that case what we needed, so in this case we will get the yield strength of that steel, and that is the abbreviation for that is the Fy, and that we write like this 415 Newton per mm square. So this is how we have to, before starting the analysis problem, what data we have, so we will write the data in form of given data. If any changes of unit is required, then also we will do that. That is the one thing. And before solving the numerical, one also advantage we have, one liberty we have in this one, that we having one Indian standard, that is the IS 456-2000. In IS 456-2000, what is there, that if most of the specifications what we have to use during the designing or analysis, that is given into that one. So where it is given to you in that document, I will also mention here. So while using that one, you can also write it that this is the formula, this is the thing which you have opted from taken from the IS 456, and this is given at this clause at page number this. Like this you have to always mention, or if you are not mentioning the clause, so if you are mentioning the page number, that is also okay. So that we have to take care that IS 456, which is also allowed in the exam. Okay. So now I will take the numerical. Okay. Before going in numerical, now we have the design steps. So what steps we have to do? Okay. So all these steps is given in, as I told you, this is given in the IS 456-2000. So in that where it is given, so most of the steps steps are given in at page number 96 of the code. So in that, there you can, so first step we will do, in that we will calculate the depth of the neutral axis. So depth of the neutral axis is represented like XU. So in that what we have, this is the formula we have. So XU by D equals to 0.87 F by AST over 0.36 FCK B into D. So what if we only have to calculate XU, so then we will easily remove this D from here. Okay, then directly we are getting XQ. This is the formula given to us. If sometime we required XU by D, then XU by D, because we have to measure this distance, compare this distance with respect to XU max by D. So in that case, we can't remove this D. So what we need to do? In that case, we will calculate only XU by D. Okay, so that is why it is needed that whatever we are using. So for that, on the basis of the situation we will calculate. We have to calculate XU or we have to calculate XU by 2. So in that, this is we have. So now in this Fy, what is the Fy we have? So Fy, as I told you, yield strength of the steel in Newton per mm square. So as I told you, grade of the steel is directly given to you. In that case, Fy you can easily access. AST is FCK we have, that is the characteristic strength of the concrete in Newton per mm square. That is also given to you in the question in terms of grade of concrete. Then after that, AST, area of the steel reinforcement in the tension in mm square, that is also given to you because this is the analysis problem. Then B is also required, so that is the width of the section, beam, the size of the section it is given. And small d, as I told you in the beginning that we having the 2D here, one is the capital D, second is the small d. So capital D is the overall depth of the beam and small d is the effective depth of the beam. So effective depth of the beam, here small d we are using, so that is the effective depth of the beam. So for that, what we needed, we also required the effective cover. Okay, so this is how we have to calculate it. This is the step number 1. In step number 2, now we have to compare the limiting values of the XU max by D. So that is depends on the grade of steel. As I told you that we having the 3 grade of steel, Fe4, Fe250, Fe415, Fe500. This reinforcement is known as the mild steel reinforcement. This one, Fe250, and remaining these two, Fe415 or Fe500, this is known as the HYSD bar. So in this HYSD, what is the high yield strength deformed bar we have. So this is how we have to do. So from here we have to compare. On the basis of that, these values are given in the IS 456 at page number 70. In third step, we are comparing it both the values. On the basis of that, we will say if the XU by D is lesser than the XU max by D, then we will say the section is known as the under reinforced section, and we have to calculate the moment of resistance by using this formula. This is the formula we have. Again, in this formula we having all the values. F by B have, AST we have, small d we have, FCK we have, B we have. So all these values we have, so easily we can calculate the moment of resistance. Second type of, if it is not XU by D is not less than the XU max by D, then if second condition arises, that is the XU by D is equals to XU max by D. Okay, so in that case we can say that the section is the balanced section, and in this case the moment of resistance is calculated by this equation. So that is also given. So in this one, this formula again, all the conditions are given at the page number 96 of the code. So what we have now, FCK, XU max by D, and all these values which we have needed, that is also we already know. So easily we can calculate the MU by D. Now the third condition is there, if the XU by D is the more than that one. So we can say this section is known as the over reinforced section. So in that case, IS 456 suggests that there is no need to do that. We have to recommend that redesign the section, means the size of the beam should be increased so that it should not be over reinforced. So these are the design steps we have to calculate the moment of resistance in a singly reinforcement beam. Now we will take the one problem. So that problem is it determine the depth of the neutral axis of beam 250 mm wide and 450 mm effective depth is reinforced with 3 bars of 20 mm. Also check the type of section M20 Fe415 grade of material, concrete and reinforcement respectively is using. So this is the problem we have. So depth of neutral axis it is saying. So depth of neutral axis means XU we have to calculate. So XU we have for calculation. So we have to do it again. So what we have to do, what data. So before solving this, we have to write first what is the given data to us in this question. So we can see that we have to calculate depth of the neutral axis. So depth of the neutral axis we know, that is the XU we have to calculate. Width of the beam is given 250 mm. So it means this is the small b we have. 450 mm is the effective depth, means this value is the small d. This is the small d we have. After that, 3 bars of the 20 mm diameter reinforcement we have. So it means this is the AST we have. Okay, after that we having the reinforcement, grade of the material. So M20 we have. So here we will get the FCK, characteristic strength of the concrete, and Fe415 reinforcement we are using. So here from here we will get the yield strength. So these are the all data given to us. So we will consider that one. So first before solving we have to write the given data. So these are the given data we have. You can see this is the given data. B we have 250 mm, D is the small d 450 mm, AST is 3 into pi by 4 20 square 942.48 mm square, M20 concrete. So FCK becomes 20 Newton per mm square. Fe415 is the 415 Fy, that is Newton per mm square. So you can see all the units are approximately similar, so we can use it. There is no need to change the units. So now depth of the neutral axis is required. So we know that depth of the neutral axis. So depth of the neutral axis is first. So we know this formula. In that formula earlier we having xu by d. So here we have to d, but in this they are asking first that we have to calculate the neutral axis, then we have to find out the what type of section we have. Okay, so type of section means under reinforced balance section or over reinforced section. So in this case what we will do, there is no need, directly we can easily calculate the xu here, because they have asked us to calculate. So now directly we will write the values. All the values already we have, f by ast, f ck, b. So we will write it, and we are getting the value, that is the 189.05. So it means if you having the beam size, that is in this, according to this question, this the size of the beam is given to you, that is the 250 mm. Okay, and small d, I think if you are providing the reinforcement, so small d is up to this. So small d is, that is given, I think, to 415. If 415 or 50. That is the 450. So that is the 450 we have. So this is the 450 mm. So your neutral axis is the 189.05 from the top. This is the xu you have. 189.05 mm. Now later they ask us to calculate the what type of section we have. So for that section we require the limiting value. So we require limiting value if we require. So we know that Fe415 grade of steel we are using in this here. So we know that for that xu max by d is the 0.48 given at the page number 70 of the code. So we will use it, and by using it then easily we can calculate the xu max, because d we already know. So d is the 450, so xu max is coming this. So xu we have calculated, that is the 189.05, so which is the lesser than the 216 so mm. So we can say the given section is the under reinforcement section. In this question they have asked up to this. If they ask beyond this, they can ask moment of resistance. So by using under reinforced section, we know the moment of resistance formula, mu equals to 0.87 f by ast over 0.36 fck xu. So that formula we will use, and by using that formula we can calculate the moment of resistance. So this is how we have to use it. So this is the end of this one. Now I have one problem for you. So this is the second problem you have, which you have to solve by yourself. That determine the moment of resistance of a beam, dimensions 250 by 350 mm. The area of the steel consists of the 3 bars of the 12 mm diameter placed at a distance of 40 mm from the bottom of the beam. M20415 grade of concrete and reinforcement we are using respectively. So now before solving, you have to write first given data. So what data you have? A beam of size this. So this is the small b, and this is the 350. So it is not defined the effective or which one it is. So we will consider it. We will consider this 350 mm is. So this we will consider as a capital D, because it is not defined that which depth it is. So we will consider it as the overall depth. Now after that, 3 bars of the 12 mm diameter we have to, means AST it is given to us, so we can easily take it at distance of 40 mm from the bottom. So 40 mm means this one is the clear cover, because they have given to you overall depth. So clear cover we have, diameter reinforcement bar we have, so we can easily calculate the effective cover. So in this case effective cover becomes, effective cover equals to, that is the 350 minus clear cover, that is the 40 mm, minus 12 mm diameter bar we are providing, so 12 by 2. So this is our clear effective cover we are having, that is the 304 mm. So this is how we have to do. So before solving it, we have to take, so this is how we have to calculate. So given data, these are the given data we have. So this is how we have to use it, and then we have to calculate the moment of resistance. This is the end of the analysis of singly reinforcement beam. So for that it is very important one, that what is the section it is. So then only you can get to know. So, and all these specifications which we use here, that is also given us in the IS 456 2000. So we can also refer that one. So thank you very much.